Shed engineering, but not as you know it. Making the parallel motion.
I'm hoping that she could be the slowest running model steam engine on YouTube, or at least she might take a little bit of beating. Oh, look at that, she's really struggling. Go on, girl, go on. Go on, yes. I wish I'd got a stopwatch, although once I get it posted on YouTube I'll be able to use the timer on the bottom. Oh yes.
Hello there, Alan Plum here again with some more from Shed Engineering. Now I tried to time that opening clip at 1 minute and I think she did 9 and a little bit revolutions. I hope you've seen the previous video where we was making the parallel motion and you saw the aluminium strap. We filled that in with some building plastic and I then started to drill out these little pieces of brass to resemble bearings. Now I tried to drill these individually, centre punching them and then drilling, but the small piece in the foreground is the result, completely off centre. You can hardly call that accurate, hence the reason why I made this little jig, and in the distance you can see a small piece of aluminium with a hole in it. That was basically the guide for the drill, and then I drilled them all together using the same little jig and a drill through them to keep them lined up. I was then able to file them down to a rough shape, and then they was all filed individually and fitted into the links. The brass pieces were actually glued onto the plastic, and the cotter pin there a little bit higher up, that is just a bolt that has been heated up to red hot and flattened down. Now we can take a look at how the rod ends were made. I don't want to spend too long on any of this. After all, it's not rocket science, and I'm sure a lot of you chaps out there can do a far better job than I'm doing, using your own ideas and your own materials. Now the rod ends were actually cut out of a piece of plate aluminium. I had made some plastic inserts. They were going to act as the bearings. Hopefully the yellow would resemble brass. I then drilled each one down the centre, and I think it was a 3mm tap that I used to tap a thread all the way through. Now before we go any further, I think we should have a word about shop safety. There's no more important rule than to keep your thumbs away from sandpaper. Then I used a piece of double-sided tape and 2 washers, and using the double-sided tape I stuck the washers onto the aluminium, centering it with a drill, and obviously that provided a lovely template that you could hacksaw the corners off and then start to file it down. With 8 of these to make, then having a template like these washers stuck on saved a lot of marking out, and ultimately trying to measure the diameter, etc. And here we see the components for the rod ends. the little plastic bushers have got a hole in it, and the grub screw there goes all the way down and holds them in place. The actual rods were made from hollow tubes, and I threaded each end of those, put a threaded rod in, and along with a couple of nuts I ended up with completely adjustable rods, because obviously they all have to be exactly the same length. Here you can see the 4 rods on the parallel motion. These 2 rods keep the links apart, and these 2 rods are the actual radius arms connecting the rear links up to a bracket which is connected up onto the girder there. So we set about making the 2 brackets with a piece of aluminium angle, drilled out and then filed. And here you see the same bracket on the Papelwick engine. You can see the drop link behind and the radius rod running down and out of shot at the bottom there. I hope you can see the similarity. So that was cut down and filed, and then using a washer again stuck on with double-sided tape, that acted as a template. And remember what I said about adjustment? I don't really want to be measuring and trying to get the holes exact, so a couple of slots in the bracket allowed for some adjustment. So here the red marker is showing the radius arm, and the green marker is showing the pivot for the crosshead. The beam actually describes an arc swinging in one direction, and the radius arm there is describing an arc in the opposite direction, and basically they cancel each other out, and the crosshead should then travel up and down absolutely vertically. So this was a major pivotal point in the build when I had to actually test whether the parallel motion was actually working. There you can see a ruler, that's actually a set square stood vertically, and as you can see it's moved down and the crosshead is still just touching the ruler. Move down a little bit more and it's still touching the ruler. Move down a little bit more and it's still touching the ruler. And so that was absolutely wonderful. I was absolutely over the moon to get that kind of precision over a 5-inch stroke, just with odd bits and pieces. Then I was absolutely blown away. I couldn't have asked for any more. Just a quick word on the geometry which makes the parallel motion work. The main factor is where the radius arm is actually pivoted, marked in red there. The length of the beam is 12.5 inches from centre to the outside pivot, so the radius arm wants to be 12.5 inches away from the central pivot, and when the beam is in a horizontal position, then the crosshead, marked in green, would determine the height of the pivot. So if you imagine the green crosshead there moving up 1/2 inch, at that point the beam would be absolutely horizontal, and it would coincide with the exact point where the radius arm is pivoted. Or let's imagine that the links in white were 1 inch longer, then you would simply move that red pivot for the radius arm down 1 inch, and when the beam was horizontal, again they would coincide. So it's not that complicated. I started off with all the rods and shafts being solid. I was actually using filing tray supports, where you get those short rods which hold filing trays up. But the solid rod was going to present a major problem, because how would I hold the radius arm on, or the links onto the beam, etc. And so when I found the hollow rod, it was relatively simple to run a tap down the inside, then grind the head of a bolt all the way down, and then obviously I could slip the radius arm or link onto the shaft and fasten it on with a bolt going down the inside. And here you see the parallel motion in operation. This has been slowed down just so that you can get a clear view, and you can see that the parallel arms are describing an arc in the opposite direction to the beam, and that's what keeps the crosshead and piston rod going up and down vertically. Now, to get to the stage where the parallel motion is operational, I had to add some girders. This is a cross girder connecting the two columns, just ordinary softwood, very crude, put through the router to create some detail. The beauty of this is that that only took 20 minutes, and if I find anything more representative of a girder, then it could soon be changed. This is a picture of the embellishment at Papelwick on top of one of the columns. I very much doubt whether I can recreate anything quite as spectacular as that. This is one of the other cross girders that the parallel motion attaches to. Again, just a piece of softwood run through the router. Hopefully it'll look a bit better once it's painted. The piece of plywood at the end is representative of the engine house wall, and the thin piece of timber there will hopefully represent stonework set into that wall for the girder to rest on. This is an example of one of the girders at Papelwick that is actually holding up the upper floor around the beam, and I hope to represent some of that, although a lot of it will have to be cut away so you can actually see the model. Well, that's 15 minutes all but gone. Next time I hope to show you the cylinder, piston and valve gear. I hope you found it interesting. If you've got any comments, by all means leave them. It's always nice to hear people's opinion. And thank you for watching.